Hi friends, myself Aniket Renavikar, Assistant Professor, Center for Distance Education, Shivaji University, Kolhapur. In program MCOM Valuation of Real Estate, the topic is cracking in buildings. In the maintenance and repairs of building, the third topic is a cracking in building. Most of the buildings develop cracks in their fabric, usually soon after construction and sometimes later. Generally, earlier cracking is superficial and easily repaired. It is unlikely to recur in future. Only rarely cracking indicates serious structural failure. However, superficial or otherwise cracking needs to be minimized and try to avoid cracking by recognizing that movement of building materials and components is inevitable and must be allowed for in design. Diagnosis of special causes of cracking is difficult. Every building is unique and several factors contribute in producing the defects, including cracking. Before one decides to treat the cracks, it is necessary to know in advance about possible reasons. First, the cause of cracking, its effect on performance of the building, whether the movement is complete, incomplete or intermittent, that is seasonal. The movements are responsible for cracking and need to be accordingly provided in the structure. The movement could be due to changes in temperature and moisture content, and the size and configuration of the structure govern the extent of movements. Their exact prediction is difficult. However, it can be reasonably worked out. Usual drying shrinkage of concrete is known through properties. Shrinkage increases with increased cement and water content. Initial shrinkage can be 50% greater than any. Movement caused by subsequent wetting and drying. Heavy aggregates attribute less shrinkage than lightweight aggregate concrete. Some aggregates have a tendency of shrinkage themselves. Initial moisture expansion of clay products after firing can be large enough, and for practical purposes it is irreversible. Major expansion occurs within the first 2 to 3 days after firing, but with normal material which are few days old in use, expansion rarely exceeds 25 mm in 30 meter length. This is just an indication to permit comparison. How cracks occurs? Cracks occur either between or within the components. Cyclic thermal movement causes displacement of units leading to cracks. It does not necessarily mean that it is failure of the structure or the components. Due to ingress of debris into the cracks, movement becomes progressive. This movement is in the direction of the applied force and frequently at the right angle. The movement of 0.25 mm in 6 meter panel can produce a bulge of 25 mm in cladding units subjected to vertical compression. This would give an idea about the manifestation. Long compound wall, terrace parapets, long lengths of structures are some of the areas which need caution. Cracking within the components, however, involves the material much more directly when building components are restrained. Their strength is often exceeded by stresses arising from movement in the materials and cracking results. A good design is based on avoiding unnecessary restraint as much as possible. Damaging traces are thus can be minimized. Next is the diagnosis. The causes of cracking is difficult to determine with absolute certainty. A repeat inspection at intervals to establish the type of tendency of the movements is necessary. It is desirable to know the building history and particularly sequence of damage, recurrence and observation. It is important that the consistency of the observations such as number, width, depth, length, location and direction of cracks and their probably modified effects on the restraint are studied. Due to this cracking response or strength response, the strength vary the effects of cracking pattern and their interaction. Therefore, repeat inspection is desired. Next is a moisture expansion of brickworks. New walls are sometimes damaged by moisture expansion, particularly when it contains short returns in the profiles. The improved course may be acting as a slip joint. This will allow the brickwork above to expand without significant restraint, and the brickwork return rotates, resulting into the cracks. If the brickwork is at least 3 months old, it can be assumed that initial expansion is complete and that the satisfactory and permanent repair is possible. Moisture expansion of new brickwork can cause trouble with drying shrinkage of concrete elements, which leads to infill brickwork under compression. The results in outward bowing of the brickwork. The size of the forces involved indicates sufficient severity depending upon the construction inputs. Whether tightness and stability are impaired and appropriate correction measures for these common defects in our construction remain unattended during early damage. These are the moisture expansion of brickworks. Next is the significance of cracking. The cracking can affect the building in number of ways. If severe, it may result in the loss of stability, rain penetration, air and heat loss, and reduced sound insulation, etc. are the outcome. All these means loss in the efficiency of the building. Generally, cracking is not severe, but it is always unsightly and unacceptable to the occupants. Correct crack diagnosis will decide whether a satisfactory repair is possible or in extreme cases economically worthwhile. Also, different settlements and problematic soils is also cause the cracking. The building constructed on unconsolidated soils are obvious to permit settlement and cracking of these elements even after repairs. Settlement of these kind of movements are often large and the diagnosis is unpredictable. Different foundation strata, partly made up and partly not, would offer perpetual problem. Also, swelling soil is important for shrinkage and cracking. Swelling soil shrinks and expands with the change in the moisture content as compared to other soils. Such soils are available in some part of India, particularly in Gujarat and other parts. Such soils are generally called black cotton soils. One has to be careful in dealing with them or to ready to face permanent problems. Sulfate attack. Next is a sulfate attack on walls and floors. Sulfate attack needs presence of soluble sulfate, cement and water. Brickwork is responsive to its damage. Parapet walls, freestanding external walls and retaining walls are vulnerable than dense rendering. Use of gypsum plaster in place of lime, cement and limestone mortars are prone to this attack. The cement in the mortar may get attacked, first causing expansion in the wall joint and resulting into typical horizontal cracking. If the stability is not impaired, it can be replaced by weak treatment using sulfate resisting cement. Next is sulfate attack on floors. Hard core of the infilling consisting sulfate should be avoided below concrete floors. Sometimes gypsum plaster inadvertently used floors. Unburnt materials from coal are known as attracts sulfate damage. It results in the arching of slab and building of walls. It is desired to replace to avoid the permanent problem rather than only the few elements locally. Next is the drying shrinkage. A common form of a cracking made within many buildings. It affects mostly construction materials such as cement, concrete, lime, plaster, particularly major decorative elevation. This cracking is quick to occur in structural areas, particularly extremely internally. High cement contents are used for several reasons. In effect, they are prone to drying.
Many renderings are used to prevent rainwater attack, and yet in fact they can crack much early. So location of major areas with familiar map pattern cracking as typical of drying sinkage. In exposure situation, the conditions necessary for sulfate attack are made up. There is a difference between two types of map pattern and the pattern of cracking.